Dear participants, online viewers, I'm delighted to welcome you back for the second day of our event on Space for Innovation in Rail conference, where we will have the pleasure to attend 2 panel sessions this morning before we head for the site visit. I have to warn, unfortunately, we've had a little technical problem with the track box at CEDEX because of the floods from last week. So we've had to cancel this visit, I'm afraid. So there are solutions, and CEDEX is offering to do a presentation in this room after the event. Alternatively, you can also register onto the other sessions where there are a limited number of places available for the Atosha Control Center, Atosha station, and the ERTMS lab, of course. So it will be first come, first serve. At the coffee break, you can go to the registration desk and put your name on the one of the other group, or stay here after the event and attend the conference on the presentation on the lab, the track box. This being said, today we will be discussing IRIS2, EU satellite communication as an option for ERTMS. Here a presentation on the application of EU space solution in technical specification for interoperability, followed by a panel session dedicated to the practical steps forward before we will conclude. I remind you that each session is followed by a Q&A. We ask your active participation, as you all did yesterday. It really enriched the debate and helps us make conclusions. For our online viewers, please use the chat feature on YouTube to comment. We will take these into consideration for our conclusions. We have planned a break from 11 to 11:30, and EUSPA has planned a nice activity for us. You will find a panel on the right of the coffee area where you can actually stick your idea, suggestion or comment on the event, on ERTMS, on satellite solutions. So please contribute, and you can go and stick a message for us. We appreciate your support on social media, so please use the hashtag Satellite4Rail when posting about the event on platforms like Twitter and LinkedIn. I remind you that this event is being recorded. It will be made available on our website after the event, and we have identified those people who do not want to be photographed. Rest assured about this. We will now move to the content, and I have the pleasure of calling on stage Mr. Helmut Spitzel, IRIS2 Project Control and Quality Manager from DG DEFIS at the European Commission, and Flavio Sbardellati, Market Development Technology Officer at EUSPA, who will introduce the session. Mr. Spitzel, Sbardellati, the floor is yours.
Ladies and gentlemen, it's a great pleasure to be here with you this morning to talk about IRIS2, the new secure connectivity program of the European Union. And my goal for this morning is to that you take away why we launched IRIS2, what it can do, and then also which opportunities the various sectors could have from this program. So with that, I would like to go into the presentation. So you will have 2 presentations, one from my side on the IRIS2 program, then you will have Flavio, and then we'll go into the panel where we can take each of the questions that you have. We have prepared a few questions, but if you have additional questions, we can also take them at that point. But if there's anything very urgent, very pressing, you can interrupt, but you can also note for later, and we'll take your question later. So in this first picture, you see the very important moment. That is when IRIS2 was born. You see the signature of the IRIS2 regulation by the President of the European Parliament, together with the Swedish Presidency, And it is Regulation 2023-588 that establishes the Union Secure Connectivity Program for the period 2023-2027, and it entered into force this year on the 20th of March. What the regulation foresees is a clear government which combines the strength of each of the stakeholders that is involved. While the European Commission has the overall responsibility, EUSPA will ensure accreditation, operational management, and service provision, and the European Space Agency ensures the supervision of the development and validation, including also the integration of the Euro quantum communication infrastructure. If we look at the current infrastructure that we have in space in terms of satellites, we distinguish between three main orbits. So what you see here is the geostationary orbits, which are in about 36,000 kilometers above us, above track, as we heard from Daniel yesterday. They have a very wide angle, a good view of the Earth, so you can direct the antenna and always have a stable signal. However, they have also other problems in terms of latency, and you see here the latency figures, which are in the order of 800 milliseconds. Now, if we go down further to the MEO orbits, or medium Earth orbits, we think about 8,000 kilometers, and here you have already much lower latencies in the order of 200 milliseconds. These two orbits are already being used extensively. The new orbit here to come, and this is also where IRIS2 will play a big role, is the LEO orbit, the low Earth orbit. And here we talk about 600 to 1,200 kilometers. And here typically the latencies that you see are in the order of 30 to 50 milliseconds. Having said all of that, satellites are not immune to threats and to intentional attacks. So it's also very important who controls and who owns them. Here's just a few examples how those infrastructures have been attacked in the past, or for example, here you have a professional jamming vehicle that is currently being used that can effectively attack those infrastructures. Now, this leads also to the objectives that we have for IRIS2. The guiding program objectives are to ensure the secure and reliable governmental service that come from IRIS2, while at the same time enabling also commercial services that are based on commercial infrastructure and at market prices. So we want to have an offering that covers the range from the governmental to the commercial part. And along this value chain, we have also looked at the number of use cases that IRIS2 can provide. If we look, for example, at the governmental services, we identified ranging from connecting EU embassies worldwide to managing critical infrastructure, be it air, rail, or road, to crisis management, and also to border surveillance. These governmental services are complemented, as I said before, by commercial services, and they should then address also the mass market, like we see in other LEO constellations that are currently already offered, but not by EU players. To be more concrete, IRIS2 will offer 4 governmental services, and these are the robust worldwide low latency service, the robust space data relay service, the assured worldwide low latency service, and the assured worldwide narrowband service. The detailed service characteristics have been set out in the Commission implementing decision this year that was adopted on the 30th of May 2023. They will be complemented, or they will complement the services that are offered under the GovSatcom Space program component. Another important priority that we have is connecting Africa, and to improve the connectivity targets that we have. It is an important business opportunity, but also a great political importance for the Commission. In addition to the services, there will be also the possibility to have additional hosted payloads on the satellites that could come from public or private actors, and that can be installed on the constellation. Here you see a detail of the services that has been, as it has been set out in the decision, in the implementing decision that was adopted on the 30th of May. You have here the exact figures for each of the services as they have been specified. And what you see on the top, out of those 4 services, 2 are considered hard gov services, so they have an extra layer of security, and the other 2 are considered light gov services. So whereas for the hard gov services we talk about robust services, in the light gov we talk in terms of assured services along service level agreements. The implementing decision, as you see on the right, has been flown down into a set of mission requirements, and these mission requirements currently are being discussed also with through the procurement that is going on for the IRIS2 constellation, and we expect then through these implementing decision, the requirements, industry will then come up with a design to fulfill those requirements. If we look at the timeline, we see that initial services are foreseen end of 2024, and full services are targeted by the end of 2027. The initial services will be provided through the GovSatcom, where the full services will be built based on what we have said here is the IRIS2 concession main contract, which is currently being negotiated with industry. On the very bottom, you see the integration with the Euro quantum cryptography infrastructure, which will happen after 2027, but where the integration is gradual, is already starting to be prepared. So to summarize the current status, IRIS2 was born on the 20th of March, if you wish, in this year, with the regulation 588. We had adopted a number of implementing decisions that relate to the service portfolio, but also for completeness, I mentioned those on GovSatcom. And also end of May, the same day, we launched the tender, the call for tender for a concession contract for IRIS2, and we launched the invitation to submit the initial proposal. Last, I would like to leave you with a word cloud that the teams from the Commission, from ESA, from EUSPA came up with at the beginning of the year. And you can see that while IRIS2 is perceived as a challenge, it's also a big opportunity for Europe to enter into, as a united player, into this new domain of governmental satellite communications. Thank you.
So, good morning, ladies and gentlemen. Flavius Bardellati from EUSPA. It's my pleasure to be here today, and I will try to complement, I would say, the programmatic and regulatory framework depicted by Helmut, European Commission, with the EUSPA perspective into the user and market opportunities which are associated to GovSatcom and IRIS2. Now, I want to start with the factual consideration. And the factual consideration is that we have entered a new era for satellite communication services. Now, historically, in the past, satellite communication services were created to support military missions, to support military applications. And then later on, they became also fundamental into the commercial market, primarily providing TV broadcasting. Now, a lot has changed since then, in the last decades. There are more and more civilian applications which rely on satellite communication services. And most important, there are more and more civilian applications which do not only need connectivity, but need connectivity with a certain level of resilience, with certain level of security, which is what we call secure satellite communication services. Now, today, secure SATCOM are used in a variety of applications without mentioning the strategic role into the Ukraine invasion. I want to mention the fact that secure SATCOM are used to interconnect embassies. They are immediately activated after a disaster, after an earthquake, after a flood, when the terrestrial means of communication, when terrestrial mobile network are compromised, or where they are not able to absorb the full capacity. They are more and more used also in transport, in aviation, in maritime, for obvious reasons. And they are used to provide primarily as a backup connectivity means, somehow interconnection of the various nodes of critical infrastructure. Now, this somehow allowed and this somehow created an ecosystem for new player in the market, which is well visible overseas in the US, China, Asia, and this also somehow gave a good, let's say, reason for the Union to create new initiatives. Okay. Now let's focus on the European landscape. So today in Europe, satellite communication systems exist. Some of them are owned by national governments. Some others are commercial. However, they are typically kind of proprietary systems. There are difficulties in making them speak to each other. There is a lack of interoperability overall. For this reason, the Union made the first step toward the creation of one initiative, which is called GovSatcom. Helmut briefly mentioned GovSatcom. GovSatcom is one of the components of the space program. It will start providing services very soon, probably already starting from next year, initial services, of course. And it will allow, on one side, to make good use of what is existing today, primarily geostationary capacity. And it will also allow to certain user communities that today do not have access to secure satellite communications, primarily because maybe they belong to member states without national assets. They will allow to all the communities, all the eligible authorized communities to access services that have a security layer, somehow giving them access to protected services that cannot be always offered by commercial partners. Of course, GovSatcom will have some limitation. It is a first step, and it is a precursor for the real disruptive initiative, which is IRIS2. Now, IRIS2 will have its own constellation. It will be a multi-orbital constellation, LEO, MEO, GEO, which means that it will be able to expand the mission of GovSatcom, both into the governmental, let's say, perimeter of use cases, and it will also have a commercial soul. It will also provide commercial services by a public-private partnership. That means that having a multi-orbital constellation, it will be able to provide low latency services, which are key for those applications in need for real-time or near real-time connectivity. It will provide broadband connectivity also covering those areas that today are not served. So it will fill the gap of the so-called connectivity dead zones. And most important, it will allow to achieve a certain level of interoperability among all these services. Finally, and this is an important point which I will also mention later in my presentation, both GovSatcom and even more IRIS2 will offer digital sovereignty. They are systems that are built, designed, manufactured, and whose services are provided and accredited by EU body. This is an important aspect. Now, I'm proud to say that these initiatives are being created really based around the user needs, around the requirements of those who will be actually utilizing their services. It was 2019 when EUSPA, at the time GSA, created the first secure satellite communication user community, user network, which is known under the name of Entrusted. Entrusted is a big consortium consisting of user representatives, both national ones, you see 15 flags there, plus EU agencies that joined forces to create the first comprehensive baseline of user requirements for secure satellite communication services in the EU. It took several months of consultations, workshops, interviews, questionnaire, but in the end, this team was able to create this baseline defining user requirements for 192 use cases after consulting over 450 user communities. It has been a massive work, but highly needed because we want this program component to be created, start taking a user-oriented approach. Now, of course, there is a lot of work to be done still, and I renew the invitation made by Daniel Lepur yesterday to really join the user consultation platform this year to deep dive really into the requirement for the real community. The requirements so far are structured in 3 macro families: secure satellite communications for crisis management, typically civil protection, law enforcement, maritime emergency; secure satellite communications for surveillance, land and maritime surveillance; and last but not least, secure communications for key infrastructure, which also includes rail traffic infrastructure. Now, the Entrusted initiative is now over. We have recently closed this initiative. However, not long time ago, a few months ago, if I'm not mistaken, it was March. In March, we organized a big event, a live demonstration in Rome, in Italy, gathering together a large community of user representatives, policymakers, industry, to demonstrate a number of things. The most important objectives which we successfully demonstrated were, first of all, how the collaboration of 2 national systems can lead to better user experience, providing also security beyond the national borders, which was not obvious and is one of the main objectives of GovSatcom and, of course, in the future IRIS2. And second point, how secure satellite communications can coexist, can complement and be hybridized with the terrestrial network. So those 2 objectives were extremely important and are, I would say, the driver for the creation of these initiatives. Now, there is a question which I think will be extensively discussed in the panel which will follow my presentation. But I also felt the need to somehow share with you some food for thoughts, which I'm sure will be very much discussed by the expert in the panel. So the question is, can IRIS2, or even better, to which extent IRIS2 can contribute to ERTMS in the future? Well, I don't have an answer, of course. I suppose that today nobody has an answer, but there are some factual considerations. The first one is that IRIS2 will provide services anywhere, regardless of the geographical location, regardless of the environmental condition. And this makes IRIS2 as an ideal complementary technology for typical terrestrial communication networks. According to an ERA study, the cost to deploy an ad hoc a dedicated terrestrial network is around 60,000 euros per kilometer. Might be more, might be less, but this I think it's a correct order of magnitude. Well, probably, and I repeat probably, IRIS2 can help lowering the cost of this investment. Maybe covering rural areas where it's difficult somehow to reach with terrestrial network. Maybe lowering the density of the base station where not strictly necessary. So overall, that is an element to consider. But then it's not only about cost. Whenever safety is concerned, safety is of course a driver. And when it comes to communication, I think that the concept of safety is strictly connected to the concept of availability of connectivity. Now, terrestrial connectivity is given for granted, especially in urban areas. But what if a terrestrial network is compromised? What if there is an outage? What if in specific areas there is no adequate coverage? Well, maybe IRIS2 can be a good allied, maybe can be a backup alternative or a backup solution that can enter into the connectivity channel when the terrestrial network cannot provide the services as expected. So the combination of two probably can also increase availability and in turn safety. Of course, there will be the need to make extensive kind of experimentation to assess to which extent this possible combination is feasible, what are the limitations, what if there are tunnels, what happens when there are bridges, what happens when the train drives close to a mountain. But this is part of the process. I would say that is part of a normal experimentation to enter a new technology into an ecosystem. And last but not least, as I mentioned at the beginning, IRIS2 is a EU system. It's a solid EU partner for whatever sensitive application. And this, I think, is particularly important when safety is concerned. Now, as I said, experimentation is needed, will be needed. The good news is that experimentation is already ongoing in the rail domain. I will not enter into the merit of what is being done in the frame of positioning, GNSS for rail. It has been extensively discussed yesterday, presented, projects, initiatives. Some of them are being done through EUSPA funding, some others outside. But the good news is that we have recently awarded one project, which we consider a very strategic project, that will also allow to experiment the integration of EU secure SATCOM services in the rail domain. Now, I cannot disclose the name of the project simply because of timing. It is being awarded, it has been somehow contractualized right now. So I cannot share the name of this project. Very soon it will come. But it is a very, very important project which will for sure add valuable element to this discussion. Now, that's not sufficient. Experimentation will be needed also in the future. Probably is the beginning of a long journey. That's why EUSPA, in coordination with the European Commission, decided to allocate further funding opportunities in the frame of the next Horizon Europe call. There is a new big call that EUSPA is about to launch by the end of the year, probably already next month. One of the topics in this call is about EU GovSatcom for a safer and more secure European Union. Now, it's a large topic. It covers a number of possible use cases, but I wanted to underline that one of the strategic use cases identified for this topic is EU GovSatcom for rail traffic management. And I repeat, EU GovSatcom has to be intended as a precursor for IRIS2. So what is being done in the frame of this experimentation, of course, is meant to pave the way for experimentation toward IRIS2. This specific topic is given an amount of 10 million euros. We intend to fund more than one project, indicatively 3 to 4 projects, meaning that each of those projects will be granted a budget of around 3 to 4 million euros. And very important, being part of this project does not only give access to funding, but also gives access to the program, gives the possibility to share views directly, gives the possibility to really be in the front line when building solutions relying on YouGov.com. I'm sure that more will come, but I really invite those of you who have interest to enter into this experimentation to consider this Horizon Europe call for this specific purpose. Thank you very much.
Thank you, Flavio, for this great presentation and also for food for thought for the panel. So I would like now to invite the panelists to come up on stage. First, Ricardo Campo, Program Manager at the Satellite4Rail Interoperability Lab, with over 10 years of expertise in railway signaling, and he's been actively engaged in projects that are innovating technologies for train location using GNSS, digitalization, and ERTMS lab test campaigns. Welcome. Next, I would like to ask Pierre Lecor to join us on stage. Pierre Lecor is working at SNCF as a project manager in innovation for telecom technology, focusing on the challenges to bring low-cost connectivity on secondary lines. Welcome, Pierre. Next, we have Marion Berbineau, Research Director at Université Gustave Eiffel, with an extensive experience in radio wave propagation, signal processing, electromagnetic modeling, MIMO, and many more. Welcome, Marion. Next, we have Fulvio Sansone. Fulvio has over 25 years of experience in information and communication technologies, specializing in satellite communication, intelligent transportation systems, and location-based services. He currently serves as the Chief Technological Officer and co-owner of SatADSL, a global satellite broadband service provider. Welcome, Fulvio. Then we have Miguel Ángel García Primo, a seasoned aerospace expert with 35 years of experience. Since October 2019, he is the CEO of Histesat and also serves on numerous boards, contributing to secure communication satellites, geoinformation services, maritime traffic monitoring through AIS satellites. Welcome, Miguel Ángel. And last but not least, we have Jose Conrado Martinez, who is the Deputy Director of Strategic Innovation at ADIF since September 2021. He has worked at ADIF for 25 years, the last 15 years in the area of research, development, and innovation. He has coordinated more than 50 projects in different areas of railway infrastructure and rolling stock, and also serves as a professor in several railway master degrees. Welcome, Jose. So, in order to get the panel and discussion started, I would like to ask two questions. The first question more focused on the technical aspects, and the second one more on the market aspects. But I will also then open to you if you have any questions to address to the panelists. So the first question is, how can the use of SATCOM in rail unveil a different and safer future? And which new options and applications do you see for the rail industry? And I would like to start with you, Ricardo.
Good morning to everyone. Before starting, I would like to thank the organization for making this possible. Related to your first question, the possibility to integrate satellite communication will offer a unique opportunity in order to digitalize the trains and also to the technologies around the ERTMS. In addition, satellite technology programs as IRIS2 defined for critical infrastructure will provide a unique experience in order to transmit encrypted data in a secure way from point to point, and also avoiding the hazards related to the terrestrial infrastructure. As a result, I would like to expose two use of case in which the satellite communication will benefit the ERTMS. The first one is related to the key management. It is well known that for the trains to be connected to the radio block center, it is necessary to have a valid key, and also this key has to be valid in time. So satellite communication could provide this secure channel in order to transmit this critical information to the trains and also to the tracks. This fact could make possible also to centralize the key management of the ERTMS at national level or even at European level. In the second case, the satellite communication will provide a good tool for the digitalization, because the digitalization requires the transmission of sensitive information to the trace in order to upload the database. So in conclusion, I would like to say that the use of satellite communication in the ERTMS framework will offer a robust, secure, and also an efficient way to transmit data to the trains, to the track, and also to the control centers.
Okay, thank you, Ricardo. If I look further to Pierre, I suppose you have looked at the same question at SNCF. What are your thoughts on this?
Yeah, thank you. I think Ricardo already said a lot about what we can do. And as you just said, railway industry has definitely started modernizing and digitalizing its infrastructure, and also the rolling stock. It's been a few years already. As this change is kind of a result of how we're seeing the train right now. Today it's no more a service than before. So we need to make the train more reliable, and for this we need high reliability of our system. So we need this digitalization to foster it. So we won't delete all incidents, but we can help the acceleration of this resolution for the recovery, and we can anticipate issue with some predictive maintenance. I got one example in France infrastructure. If we got no cellular network, the driver has to walk on the track to an emergency phone. So this can take a lot of time, because this phone is deployed every kilometers. Just for this degraded situation, we can understand that SATCOM is a really good solution to help the recovery of the rail track. So then with this connectivity, we can rely to a lot of new use cases, as we already said. So it can go from real-time supervision to do predictive maintenance, as already said, and we can go up to automated train. So the automatic train will go with CCTV, it will go with video supervision, it will go with remote driving if we get an incident. So this is really use cases which needed a secure solution. And I think SATCOM with Leo and IRIS2 is a good solution. So this is not a complete panel, but this is a few examples of application, I think.
Thank you, Pierre. How does it look? Yeah, Mario, if you would want to continue, also a little bit from the research perspective.
Yes, I will insist on the research part on this second question.
Okay,
but,
okay.
I just want to add also in the presentation of myself that I am vice-chairman of Urnex Association, which is a network of academia working on the railway domain. So it is very interesting for you, industry and railway operator, if you want to build research and innovation action with experienced universities. And I was also nominated last year as a representative of academia on the academic group at ERAC. So this is to show that even as a researcher, we are not only dreamers, we are very close to industry needs and requirement and railway operators. I am involved in wireless communication for railway since 1989, so I'm not so young, and I was part of the great venture of GSMR. And for me, satellite, and I think satellite are a very big opportunity for railway. For example, satellite can help harmonization. And yesterday, I think Philippe Citroën spoke about interoperability, and I think satellites could be a vector to reach this. I think we already have the vision that satellite will not operate alone. In shift to rail, industry has already developed adaptable communication system, and I think the key word for the future, from my point of view as a researcher, is adaptability and reconfigurability. And this is possible. There are technologies, I think, that industry can go through what we call cognitive radio, what we call dynamic frequency adaptation. One point very interesting for satellite is that frequencies are already allocated for everybody in the world. So the fight for frequencies in the railway domain is already done, because this is really a problem. If we want to revitalize all the small lines, we will need bandwidth, we will need radio capacity, and the problem is very low band. And today, for governmental aspect, frequency bands are not a priority for railway. They are a priority for Internet of Things. Why they are not a priority for traffic management? I don't know, regarding the second part of your question about costs.
I would suggest we first do the first round on the technical aspects, and then go into the other ones.
Okay.
Okay, thank you, Mario. When you bring up adaptability and reconfigurability, this is also a very important point that we keep in mind when we develop the IRIS2 constellation. So the industry is currently developing, but we know we also on the satellites want to be able to upgrade if we have new technologies that are coming. So this is something we're also looking at very closely.
What is important is not to put several modems in parallel, which is not really economic from a frequency usage, but to go to real reconfigurable radio.
Thank you, Mario. Now, I would like to ask to Fulvio Sansone, what do you think on the prospects for rail of SATCOM?
Thank you for the question. Maybe I will just explain in few words what we do, so to make it a little bit more clear to the audience. SAT ADSL, that now has become Nexsat, is a satellite connectivity provider. So basically we buy satellite capacity from satellite operators like Hisdesat, or let's say for the time being more from the commercial market, and we transform this raw capacity into services for the end users. So I'm not an expert of rail, and I'm not able to give ideas about the applications and the usage, but we know what we can do and what we can make available to the users. And we are offering services for a number of other mobility use cases, and we are not offering services for rail. So I was wondering why, how is it possible? Now I start to understand what is the situation. For us it's very important to be here and to learn from the experts and to understand what are the use cases. What I can tell you is that the satellite community, one thing which needs to be clear to the users is that satellite communication and what the colleagues from EUSPA and European Commission have presented is showing this very clearly. Satellite communication are undergoing a huge revolution in the last few years. We are coming from a time when satellite communication was extremely expensive because, of course, sending a big object in the sky or many big objects in the sky costs a lot of money. And the technology was such that the form factors of the terminals that you have to use on the ground was quite bulky, if we can use this expression. All this is changing. It's changing at a pace which was impossible even to imagine a few years ago. So things are going to change and are going to change a lot. And we see that the European Commission has a very aggressive plan in terms of development and deployment of a system which will have to have certain capabilities, and we have seen that others, unfortunately, in a very vertically integrated approach have done elsewhere already. So it's possible. So this means that satellite communication can probably help you in achieving your own goals, and we are ready to help as much as possible. So I would say from my side, the message is the technology is changing, the technology is becoming more and more affordable, so I am sure that there are ways to have those two worlds to meet up and help each other. And one of the things that I was, as a neophyte, I was noticing, if you go on the ERTMS websites and so on, you see that there is one thing, one pillar, which is GSM-R. Maybe we should have another pillar, which is SATCOM-R.
Thank you, Fulvio. Let me address now, you said you cooperate with Histosat and other SATCOM providers. Miguel Angel, what are your thoughts as a SATCOM provider? What do you foresee, what can you bring to the future of rail?
Okay, thank you very much, Helmut. Ladies and gentlemen, good morning to everyone. Thank you to be here in us, and let me start say thank you to the organization to invite us, to invite me personally. It's an honor to be here and to share the table with my colleagues here and with the introductors of the session, you and Flavio. Let me start a little bit explaining what is the SAT, and after that I will go through the application, what the satellite can do for the rail. So EUSPA is a SATCOM operator. It's a GovSatcom operator. So we are the operator of the Spanish satellite fleet. We do in a way of public-private partnership with the Spanish government, in particular with the Spanish Ministry of Defense, and we then be a GovSatcom operator. GovSat operator, more than SATCOM, because we have a satellite communication fleet and Earth observation as well, and I will introduce later on that also Earth observation could help the rail system. Well, as I mentioned, we are working in SATCOM currently in GEO. We have several satellites in geostationary orbit, and we are developing new generation of satellite called SpainSat Next Generation, that today are the most advanced and secure satellite manufacturing in Europe. And of course, we are already prepared to contribute to GovSatcom program. Of course, we are working with EUSPA, we're working with the Commission, and also looking forward to seeing starting the GovSatcom hub that will push all of these users of the GovSatcom system. In addition, we are part of the 11 companies in Europe that we form the consortium and the core team that we are negotiating. We provided an offer to the Commission, and we are negotiating with the Commission for the IRIS2 program. We are a lot of target to be fulfilled, but we are really very happy to be there and also very convinced that we will go with the most advanced and secure system in LEO orbit for communication. And also we are in Earth observation, so we have a satellite called PATH. It's a synthetic aperture radar with a very, very high resolution. So what we can do from the satellite standpoint, of course, my colleagues already introduced all the SATCOM capabilities, plus yourself is there, so we have full coverage of Europe and of the world as well. Of course, we are not dependent, we don't need terrestrial network deployments to provide the communication, so it's almost immediate to be done. It's not affecting as well, and this is very important nowadays, by natural disasters, because the terrestrial network, unfortunately, are heavily affected by earthquake, fluids, or whatever. And it's not the case of the satellite. So we can maintain this resilience for the communication in addition to the secure one. But not only telecommunication. Let me tell you that also from Earth observation we can provide services very important for the rail system. So, for instance, with PATH, we have a very high resolution interferometric mode, and we can measure subsidences of the terrain around few millimeters, 1, 2, 3 millimeters of movement, in this case of the rail tracks, in the vertical direction. So that's very important to prevent any potential incident in the rail track, and also is very helpful for preventive maintenance. In addition, with the Earth observation satellite, we can do what is today a fancy issue, that is a digital twin model of the full rail track in Europe, and we can also update that model almost in real time through our Earth observation satellite. And with the telecommunication, we can also broadcast that digital model from the railway to any train that are moving in Europe very easily. So thank you very much for that question.
Thank you, Miguel Angel. Jose, I would like you to reflect on the question. I suppose you have done many projects already in the field. What have you learned? What projects do you plan? How do you see the future?
Thank you very much, Helmut, for your question, and thank you very much to my colleagues. Thank you very much, everyone, for your attending this seminar. And one comment to Fulvio. I don't am an expert in satellite technology, but I think that is a good combination in this panel with different specialists because it's the future. We need to collaborate with the satellite sector. Okay, in general terms, for a company like ADIF is an infrastructure manager. The use of the SATCOM could be an alternative in those points of the track of the network where the installation of the terrestrial solutions, communication, or the infrastructures of this system are not viable. Okay, our colleagues from EUSPA present in the presentation and the before presentation this aspect, because this could be the case for the low traffic density lines. For this type of lines, our analysis is clear. The use of this type of communication is very, very important. If we consider the voice communication, no data communication, typically in the railway service, the voice communication is less critical than the data communication. But however, it will be always be safer for the driver to be able to connect with the control center. Is a priority. For example, if we have an incident in the line, it's necessary to use a communication system, and in this type of lines, the SATCOM communication, the SATCOM system is a good alternative. This is, from my point of view, if we consider in this moment that there is not the ERTMS equipment in the line, we imagine a line without ERTMS, or a line with very low density. The use of the SATCOM for voice communication, for me, is a reality in the medium place, in the medium terms. In our case in Native, we have a singular project in a line in the south of Spain. It's a line with 18.5 kilometers between a Spanish city and the border with Portugal. And in this line, we are decide the use of the SATCOM system only for voice communication, and is a line with very, very low density of trains. And in this line, we are not used in this moment in ERTMS system. The conclusion is that the voice service in this type of situation, the scenarios, in the term, in the short or in the middle terms, is possibility to use the SATCOM. In the positive, the use of the ERTMS system in the lines is more complicated. It's more complicated. In this case, we use the data communication also, and the use the satellites is more complicated because the specification must be clear in this moment. Okay, but I think that in the future is the challenges of this type of the topic in this moment. Our objective is that the SATCOM systems, the satellite communication, the IRIS new standard can integrate in the railways operation. Okay, this is in general my opinion in this moment, the infrastructure manager's point of view.
Thank you, Jose. At this point, I would like to ask you if you have any additional questions that are along the technologies and how SATCOM could be used for rail. If you have any questions on use cases, yes, please state your name and your affiliation. Do we have a microphone? And also please state who you would like to address your question to. And so we stay now still with the technology part. 1, 2, 3. 1, 2, 3. Okay. And okay, yeah, good.
Good morning. My name is Michel Russen. I am the managing director of the ERTMS users group. Very interesting. This information you're giving, but it raises a couple of things. First of all, Fulvio, you mentioned that you would like to see another column in this ERTMS website next to GSMR, SATCOM-R. That's a wrong idea.
Thank you.
And I will tell you why. Because there should be one column which would be called FRMCS, and SATCOM should be part of FRMCS. So that is a little message to you, and to Marion, because you were involved in GSMR. How come that we ended up with rail-specific systems? What we should not have is that we end up with communication systems for which we actually have only a very small supplier market. So we have to, and we have an opportunity in the railway sector to do that, but we should not lose that opportunity now. And maybe you can help over there. Thank you. And then finally, Jose, you talk about regional lines, and you talk about that maybe satellite communication could be a good way to do that. But you don't mention that these regional lines have no protection at all. They do not only have ERTMS, they don't have ERTMS, they don't have any protection. And imagine if you would just use, if you have a satellite connection, also to install a very simple ERTMS system on those regional lines. So don't talk about the voice communication only, do it immediately in combination with installing a train protection system over there called ERTMS. Thank you.
Thank you. Okay. In this case, maybe we can already take the second question so that we can be very effective in answering to those. Thank you. Yeah, okay.
Miroslav Haltov, Chairman of the Europe's Rail States Representatives Group. I very appreciate all the presentations and very impressive discussion, but I have a comment or some remarks to the one of the slide, which was mentioned the traffic management system. And the traffic management system is a very important part, but it's not only one. There are different layers on the traffic management system, which also need different services, maybe from the satellite services. And especially the safety-related services are one layer. It's the ensuring and make safety moving of trains on the infrastructure. Then we have the second layer, which deals with the information for the management of staff, management of assets. So we need to know the position of the train, exact position, delay, and so on. So some calculations are needed. And then we have the services, how to ensure the order of train in the infrastructure. So all this means the priority of the trains and crossing on the single track lines, etc. So for all the services, we need also different services from the satellite offers. Can you tell me if there is some idea how to separate these services or how to use the services differentiately related to each layers of the traffic management system? Thank you.
Do you want to address it to anyone in particular? I will ask the panel later. So think about it. Okay. And then we have a third one here.
Hello, Jorge Iglesias from FedEx. I have a question related to the question given by Michelle. It's related to we are all thinking in the dream of not having a dedicated telecommunications network for every line, which is with a very big impact in the cost of the lines, which is what we have with GSMR. And my question is related to the FRMCS. I don't know, Marion, perhaps you know more than me, I'm not an expert. Michel told that FRMCS will include the satellite telecommunications, therefore will include the possibility of having a line without any infrastructure for telecommunications, and we will use the space which is not free, but much cheaper than having a dedicated network. Do you know something about this? And also about the time for FRMCS, because this is another question. We are expecting many years, and I don't know if it will be available soon or not. Thank you.
Okay. And let's take the fourth question and then give the panelists, there was a question in the back.
Hi, I am Carolina and I work for ISDEFE. And I know that most of this has already been mentioned, but could you make a recap of all the challenges that would be the implementation of SATCOM networks in the railway system, please? Thank you. And probably could be answered by, I don't know, José Conrado Martínez or Miguel Ángel García, probably?
Okay. Thank you, Carolina. So, okay, we have had a number of questions. The first one was on the FRMCS. So who would like to take this point, Mario?
Yes. Regarding FRMCS, I would like to remind that a keyword is multi-bearer and adaptable communication. So I think that FRMCS is a good way at the moment to avoid the error we did with the GSM railway. But I I always try to warn my colleagues in the project that we can experience the same error with 5G if we rely only on the public operator willing. I know perfectly that, for example, from a technical point of view, it is possible to share a public network with different users, with different level of safety, thanks to what we call slicing. And this is technically possible. This has been demonstrated. The problem is that is the cost. So if there is no push from the government to say railway is a priority for the future world if you want to decrease the use of fossil energy, so I think technology is there to avoid to have a dedicated system, but I think we have to be careful. We have to be careful in having multi-bearer. So I think that with the adaptable communication system, using several modems, it's a good way. Satellite is included. We will have normally some project on this to demonstrate the possibility of using both satellite and terrestrial network. In the ICT program, you have a lot of European projects working on this to have a switch or a seamless switch between satellite and but we have to remain careful not to have industry selling a proprietary solution. I am thinking about, for example, proprietary solution for coexistence between GSMR and GSMR and other system in the GSMR band. So this is, I think, one of the error of GSMR was proprietary solution.
Okay. So I think this addresses also part of the market question, but there was another question to Jose on the regional lines. On the, you said it was for lines that have no train protection installed.
Yes. No, I agree. The regional lines. My reflection when I comment the first question is that in the current situation now, okay, the use of the SATCOM system in this type of lines. For example, we have in Spain different lines in this moment without ERTMS system. The idea in the future is the new standard for the regional lines, or the new regional ERTMS. I think that low cost ERTMS or regional ERTMS. We are in this moment working in a test project, in a testing project. But my reflection is in that moment. Okay, in this moment, I think that the use of the SATCOM system for voice communication is a possible real scenario. But in the future, it's necessary to migrate to the new standard. This is, for us, is a main objective in this moment. Okay, but this is my reflection. Okay.
Okay, I see.
No, sorry, we are beginning in this moment a pilot project with a new standard of ERTMS, low cost ERTMS or regional ERTMS in a specific low traffic density lines. And the idea for in this moment we are not defined how integrate the communication in the project. I don't know. This is, for me, in this moment, a question. Okay.
Okay, Fulvio, I think you wanted to react as well.
I wanted to reply. I mean, of course, we are not experts of the sector, so we rely on you on how to best place SATCOM in FRMT whatever. I will learn it one day. What I wanted to also to highlight is, and this is something which what Marion said made me think about, which is the relying on a proprietary, the danger of relying on a proprietary system. Consider this: satellite communication have naturally implemented one of the main drivers of most European governments of the last few decades, which is the separation between the ownership and operation of the infrastructure and the provision of services. Satellite operators, generally, they operate satellites. There are some who are selling also services, but generally there is a vibrant ecosystem downstream of service providers. We are an example of service provider. We do not own any satellite. We don't even own the teleports, the big antennas which are pointed to the satellite. So we partner with satellite operators and teleport operators, and we concentrate on providing the service. We have developed a huge large infrastructure in order to do that, traffic shaping, routing, plenty of stuff for value-added service, but we concentrate on the service provision. So it's what most governments are looking for in the telecom and in other sectors, all sectors where there is an infrastructure involved, separating the operation of the infrastructure from the service provision. I think that this is a value added which goes in the direction of interoperability, not being dependent on a single solution. If you go with one satellite operator, then it will be one satellite operator. If you go with the service provider can use any satellite which is available in that region, depending on cost, coverage, and so on. One challenge that we have for the future, and this is a challenge that I bring forward to the institutions, is to keep this vibrant downstream ecosystem. So the fact that institutional bodies are entering somehow with goodwill, of course, I do not put any doubt on that, but the one thing which needs to be kept in mind is that those markets are existing markets where there are already a number of players. What the institution needs to facilitate, to trigger even more that market, but they should not damage this vibrant ecosystem which is already existing. So this is one of the challenges I think that exist for the European Commission, for the EUSPA, for the institutions in building those infrastructure and helping us going out of the control of one single company in the US that makes everything from the satellite launchers, service provision and so on. I don't want to make advertisement for them. And to be able to use other infrastructures, other capacity, European capacity, sovereign capacity, it's very important for us, but all this needs to be built in a way that downstream the service provider can continue to exist and make their business.
Mm-hmm. Thank you, Fulvio. We had also the question on traffic management system and the different layers. Who feels... Okay, Ricardo, please.
Thank you, Miroslav, for the question. So Helmut did a presentation where he presented different services, like hard-gov, light-gov, and public service. And from my perspective, that totally fits with the railway requirements, because we have safety critical information, for example, key management or ERTMS. We have critical information that will be ATO, automatic train operation, or even digital maps. And also we have other information like passengers information that it can be transmitted through public service. So I think that IRIS2 totally fits the requirements at a high level of the railway and also the traffic management with these different layers of security. Thank you.
Thank you, Ricardo. And last, maybe it was Miguel Angel, on the overall challenges, just as a, well, what are the big challenges?
Okay, thank you. Very quickly. So before going to the challenging, I will go now, and to address the question from the last question. The SATCOM capability can create, a specific channel per specific services within the ERTMS system. So that's completely possible, and each channel could have their own security, their own moderation, everything. It is important, as Fulvio said, using, let's see, transparent satellites, not proprietary. I mean, there is satellite that you can use only their own proprietary ground infrastructure and ground terminal from some satellite operators. We do not do that. Our satellites are fully transparent. Even our new satellites are fully software-defined satellite and flexible payload, and we digitalize the signal and so on. We are still maintain the transparency of the full satellite, so we are compatible with any kind of modulation, any kind of waveform, anything. So that's very good, and that's very important. Regarding challenging, of course we have challenge here in front of us. The good thing is the space infrastructure is there. So we have already some capabilities in GovSatcom, mainly in GEO. Some low Earth orbit is coming with IRIS2, but as Helmut said, probably we can start next year initial services based on GovSatcom GEO capabilities. So that's done. And in my view, the most difficult thing and challenging thing for rail is to develop and implement all the ground terminals, all the terminals in the trains and so on that is necessary to deploy in order to keep fully connected all the rail system by satellite. Of course, there is some other difficulties that I think we mentioned already. There is tunnel, there is other things that need to be solved as well. But there is technical solution for that can be implemented. And in my view, the most challenging, again, because the number of terminals is very, very, very important, is all the ground infrastructure. The good thing is also due to the high number of units, I think the price could be reduced very, very, very heavily. And also new technologies coming. We can go to flat antennas, terminals with no volume, can be integrated very easily in the train. So now these things are fully possible.
Thank you, Miguel Angel. I would like to come now to the second question that we have prepared for you. And this is now going more into the market part. And as Miguel Angel said already, price is always a consideration for any equipment that you need to install. So I would like to again make a quick tour. We have about 11 minutes left, so but maybe the questions can be done in the coffee break on a one-on-one basis. But to give you some input for those questions and for those dialogues afterwards, I would ask each of the panelists to give us a quick input, a quick thought on how the use of SATCOM can potentially decrease the cost of railway telecommunication in the future, and which trends you foresee. So now I would like to start with you, Ricardo.
Thank you. So for this question, I would like to focus on ERTMS and critical operation. So I will expose 3 areas of use in which the satellite communication will reduce the cost. The first one is related to local implementation. And by local, we mean projects in which the satellite communication will facilitate the deployment of the ERTMS on lines or even on countries, for example, in other continents. The second one is related to a global implementation, and for example, is a seamless handover between the RBCs in the cross-border sections by the use of satellite communication. And the third one is related to the critical one, and is the digitalization and the technologies around the ERTMS as automatic train operation, digital maps, or the GNSS augmentation information. So by considering these 3 options, we can make the ERTMS not only more accessible or cost benefit, we can also promote the innovation and to make the operation more reliable. And just to finish, I would like to note that for satellite communication to be effectively integrated in the railway environment in safety critical application, it is needed by the sector to define the requirements they need in order to be part of the future FRMCS. So, thank you.
Thank you, Rodrigo. Pierre, what are your thoughts?
Yeah, thank you. So I think for the cost, first element of answer has already been shared. With SATCOM, there will be no infrastructure, so this should decrease the cost. Nevertheless, Warning Star could really suffer of this. And the second point is, a lot of people already talked about this. We already got FRMCS with 5G ongoing. So the GSMR we have right now, we will change it by FRMCS. So this brings me to the fact that in a long term, I think it's more secondary lines, at least for France, which is our main goal for SATCOM technologies. If SATCOM is bringing enough throughput and stable low latency connectivity, we can be sure that SATCOM will be adopted by a railway company, at least for these secondary lines, because right now they're not really keen to bring it to high-speed line and so on. Marion said already, just before that, with FRMCS, we need to get multi-bearer connectivity. Right now, they don't really want, at least for SNCF, they don't really want to hear that. They just 5G, private 5G. They don't want public MNOs, they don't want satellite or other things. So we have to play with the secondary lines to prove them that it will work. So SATCOM for CCS, it will work, SATCOM for supervision, and if we manage to get enough throughput, I hope SATCOM for IOB, Internet on Board, because we know that's something that will bring people on board, because they want to get to be able to work, to be able to stream media, something like this. If we want to bring them to us, we have to do this. And this is an objective for SNCF to multiply by 2 the number of passengers in the next decade. But even if SATCOM seems like a wonderful answer, we still have to test it, experiment it. Right now, I really expect that it will work, but we know that there will be tunnels, there will be forests, there will be a lot of stuff not helping us. So it's, I think, just a part of the answer, and hybridization will be maybe the solution, just like we said before. So using terrestrial 5G, SATCOM, maybe some other technologies. There was millimetric waves also coming, maybe it's on the ID. And the last point, which is, I think, kind of weird for railway, is that SATCOM technology is quite a short life cycle. A constellation is like, a satellite is 5, maybe 7 years old, and then we're changing it. So if we want to be sure that constellation, we need to be sure that constellation operator will keep running the services after this time. Otherwise, rolling stock will just never go through it. If they need to change antennas every 5 or 7 years, it will be a mess. So that's also, I think, the last point, and not the wise. Thank you.
Thank you, Pierre. Just to add, we do not want to keep the constellation just up for 5 to 7 years, but for Galileo, we always talk about 100 years, at least. So, okay, Marion, please.
Okay, so I think a lot of things already said about the potentiality of reduction of cost. What I want to say is also, please do not forget research. To start with research, and research is not only testing codes. With researcher, you can, if you made research at the beginning, you can have a new vision, new cutting-edge system architecture, because if you just create a modem with concatenation of several modems, this is not research. You have to imagine something more durable, less energy consumption, less flexible, more flexible, and things like this. For example, we know a lot of people said for GNSS before that, oh, I will take something from aviation and I will plug to the train. But we have seen that it is very difficult. I think it is the same for SATCOM. There are a lot of points to be solved. For example, the problem of coverage, the problem of cyber security, because cybersecurity requires energy. So if we want, there are some technical possible solution with virtualization of function in the network, with edge computing that will allow to decrease the load, computing load in the satellite and to report on the network. So I think it is really the good timing for railway and for research. So I hope that the European Commission, with all the different entities, will put some money for research and innovation action to provide a new solution for antennas, for if you build an equipment very high cost for rolling stock, is not a good solution. I remember some years ago, EUSPA from Thales telling to the question, what is the future of railway? He said, signaling on the cloud or in the cloud. So I think it's a good vision. I think there are a lot of technologies already on the table, but on the research side, and we are ready to bring this knowledge to you. And just, it's not the question, but I think there is a lake of young competencies, and academia can help you to train or to bring on the market of industry new engineers with satellite competencies. And I hear everywhere in Europe that it is very difficult to find young people with these competencies. So I think it is urgent to train and to make young people dreaming about railway, and perhaps satellite is the vector to dream.
Okay, thank you, Marion, for this passionate appel. As Flavio mentioned, there are opportunities. There's Horizon Europe, and there will be, I'm sure, many more activities that EUSPA will launch in this field that will hopefully also stimulate the research in these areas, as you mentioned. Fulvio, what are your thoughts?
I fully agree with Marion. Let me be provocative and be hyper simplistic. I mentioned two numbers, 302. You means, what does it mean? I tell you. Today, without any subsidiation, we can offer satellite connectivity for prices which are $300 for a terminal, complete, dish, modem, cables, everything, and services for $2 per gigabyte, which is comparable to what you pay with your mobile, or even cheaper than what you pay with your mobile when you are roaming outside Europe. So it's the challenge is, how can we bring this kind of prices to a solution which is rail grade? And there I think that what Marion was telling about research and development is a key, because we have to be able to bring those level of costs into an application with some specific requirements in terms of both form factor of the terminal and characteristics of the terminal, and in terms of security of the service.
Thank you, Fulvio. Miguel Angel.
Thank you. I would like to first put the difficulties of the equation of increasing reliability, increasing security, protection, resilience, and reducing price. Typically, this is a very difficult equation to solve, but and I believe with SATCOM capabilities there is some factor that can help. So, as mentioned several here, I will tell you the first, in my view, is that we have already some space capabilities and satellites, SATCOM satellites, and other that are planning to come in, like IRIS2, that are not fully dedicated to railway. So they are dedicated to thousands of government applications. So at the end, and for the rail system, it's not necessary to create a new SATCOM system for that. So that's important, because otherwise the cost will be a lot. And the second important matter is research and development, because it's true that here is an opportunity to create or to develop thousands of ground terminals, and it's the time to to introduce new technologies there, miniaturization of electronic, active antennas, phase array antennas, and so on and so forth, that could create very cheap terminals, even cheaper than already are, and reduce the price for the total services.
Thank you, Miguel Ángel. And now we have Jose as the last intervention.
Yes, thank you.
Feel free to add anything besides cost.
I am very fast, because we are in the time. Very briefly, for an infrastructure managers, the economic viability of the SATCOM communication system increase when we deploying a railway communication system on a new line, or we renewal the communication system in an operational line from the beginning. Okay, is much cheaper respect to the terrestrial solution. This is my conclusion. Another problem, if, for example, in our network is a critical problem, is the orography. But this is another aspect. The orography, because it's very difficult. Normally, you need in the future we need continuous installation of terrestrial communication in a lot of lines because we have a lot of tunnels, a lot of sites or sections with a bad coverage of the satellite. But this is another problem. Thank you.
Thank you, Jose. And with that, I would like to conclude the panel. So many thanks to the panelists for entertaining us in this panel. Please give them a big hand. Thank you.
So it is now the coffee break. I remind you, if you want to register to the visit instead of the Trackbox lab, please go to the registration desk straight away. If you don't intend to participate and you were planning to, please cancel as well. And please make your contributions also on the panel with Christina next to the coffee. Thank you.